Today we're going to learn the maximum normal stress theory. Now this theory was developed by William Rankine in the 1800s. It is a theory for brittle materials, and it was one of the first theories that were proposed. The theories is defined as failure beginning when the maximum principal stress in a stress element exceeds the ultimate tensile strength of a material. Now, William Rankine was around and active in the 1800s, Scottish mathematician and physicist, one of the founders of thermodynamics, and the introducer of stress concentration factors and fatigue methods. This theory is one of the simplest theories to apply. We're simply going to evaluate whether our principal stress, if our principal stresses exceed the ultimate tensile or compressive value, then failure has occurred in our structure. Criterion is defined as two equations. If first principal stress is greater than the tensile strength, or if the third principal stress is smaller than the is more negative than the compressive stress, then yielding or failure occurs. To turn it into a design criterion, we simply replace the inequality with an equal sign and divide the property by n, our design safety factor. Now, what happens when we plot this very simple failure theory? Well, what we'll see is that in a certain quadrant, it performs well to experimental data, but in another quadrant, it vastly overpredicts or is non-conservative to the experimental data. So, in general, this theory, while one of the simplest, is not recommended because it's unsafe in that fourth quadrant. But we still include it for historical comparison and because it is kind of the simplest, the most classic one that we know of. There are other brittle theories that do a better job that we're going to learn about. And with that, we're done with maximum normal stress.